Alright, hello, this is going to be Solidworks CSWA practice problem 6.12, and if you want to follow along with the video, make sure to follow the link in the description, which will take you to the official Solidworks practice problem database. So let's get started. So we are going to make sure our units are in MGS, and then let's set up a sketch in the front plane, and set up a revolve. So to do that, we'll have to get a vertical center line for our axis of revolution, and then I'm going to yes, I actually think I'm going to start from the top. So I'm going to click center point arc, and so I'm going to start with the sphere part at the top. So you're actually not given a dimension for its diameter, so you can't just draw a circle. But the only thing you do know is that the center point is coincident with the center line. So we'll just create a center point arc for now. I'm not going to finish all the way though. Just leave it there. And then I think I'm going to use my tangent arc tool. And I'm just going to draw the general outline of these arcs, which will all be tangent to each other. And here I'm going to make sure that this endpoint of this arc is vertically aligned with this intersection right here. And I'm going to create another arc. And then the final arc. And I'm going to do a similar thing where the endpoint of this arc is vertically coincident with this intersection. And then I'll just close it off with a base like this. Oh, where's my line? Like this. But of course we actually have to add those constraints because that's just the that's just the auto detection tool. It doesn't actually constrain it for you, just lines up the geometry. So we'll have to do that ourselves. So let's make those 2 points vertical, and then this corner point with this arc intersection point vertical. And the reason you need to do this is because there's actually not enough dimensions provided in the drawing to fully define your sketch. So you have to do this ahead of time to make sure it's fully defined. And so we'll start dimensioning this. So the distance from the sphere center point to the bottom is going to be 24. And then the distance between the base right side, its total diameter at the bottom, like this, is going to be 14. I guess I'll add these vertical constraints a little later. First of all, let me add the dimension. So this is going to be 14. Let's see if this works. Yes, that works. That's 14. And then the distance between this center point right here of the middle arc and the bottom is going to be 10, vertical distance. And then the vertical distance from the first arc center point and the bottom is going to be 6. And a first arc is going to have a radius of the first arc is going to have the radius of 4. And the second arc is going to have a radius of 2. And now I'm going to add those vertical constraints I was talking about earlier. So this corner point and this arc intersection will be vertically constrained. And then, yes, this arc intersection will be vertically constrained with this arc intersection. Vertical. Oh, no. I actually made this wrong. So this one is supposed to be R4. Oh, the third arc is supposed to be R4, and then the second arc down here, the one that you can barely see because I did it in the wrong order, is actually supposed to be R2. So that's okay. That's where it is. Yeah, I was wondering why it looks so weird. I selected the wrong arc for the R2 one. But it still has this vertical constraint, so it should be fully defined. So then I'm going to close it off, but I'm not going to close it off all the way. I'm going to hold off until it's about vertical with that center line. And kind of going to just like wrap around it like this. And this is going to be the hole that's going to be made in the middle, which has a diameter of 7. So the distance from this hole's right side to the other side would be 7. Should be a fully defined feature. Yes, and these two are coincident with each other. And I'm just going to trim away this extra line at the bottom, like this. Or maybe do I keep that? Maybe I do keep it. Okay. Or maybe because the... Actually, no. I don't need to keep it. I think pretty much all I need to do is just dimension this part. Oh, never mind. I'm just gonna keep it. Okay. So I guess I definitely will just keep this. I'll just do a revolve cut later. So I'll do it like this. Okay. So I'm just gonna revolve extrude this. So features. Revolve boss base. Let's get 360 on that. Select the axis. Oh. Axis of revolution should be this. Contour will be. Oh! Oh, no. Okay. So you didn't actually have to get rid of this line. You could just keep it, but just not select the contour. Just select everything around it. And you'll get the hole in the middle. Okay, that's perfect. Okay. So you check mark. And there's the hole. Perfect. And all I need to do is just add two perpendicular circles, or holes, I mean. So, yes, you have two perpendicular holes, and both of those holes will be offset by 4 millimeters. So I'm going to draw a sketch, choose any plane, front plane. There's a front plane. Let's create a hole. Let's create a circle. I mean, let's make it vertically coincident with the origin. And make sure it's 25 vertical from the origin. And then let's make sure it has a diameter of 8. Then let's make that cut. It's an extrude cut. But instead of just cutting like this, we're going to offset it. So click from offset. And the offset is going to be 4 millimeters. And the cut is going to be just a through-hole cut. Yes, so it's going to be offset by 4 millimeters, and it's going to be a through-hole cut. So I'm going to select OK. And then we're going to create a sketch on this side. So we're going to do a sketch, should be a right plane. And then we'll do the same process, just circle, vertically coincident with the origin. 24 from the bottom. Eight in the diameter. And let's do the extrude cut. So this time it's cutting to the right, but I obviously want it to be perpendicular, so I need to offset it forward to the left. So I'm going to click offset 4, and that should be perfectly perpendicular right there. Yes. Yes, wait. Yes, it is. Okay. So I'll select OK. And you can even see from the inside, it is perfectly perpendicular. So I'm just going to cut like this. It's all good. Okay. So there's your two perpendicular holes. And then now we're just going to check the answer. Let's go to evaluate mass properties. And for your volume, you're going to have 4,630 cubic millimeters for your volume. 4,630 cubic millimeters. So I hope you learned something from this video, and I'll see you in the next one.